Hello, my dear students. Welcome to NAK Academy. Today we are going to discuss the chapter perimeter, which is the very first chapter of grade 10 syllabus. So, before we discuss perimeter, we should know what a plane figure is. Basically, as you all know, if I say examples as rectangle, square, triangle, all these figures, you will find these are as a close-ended figures. In other words, close-ended means all three sides or four sides or whatever the number of sides it has, which are closed, which is not open at any point. So in order to calculate the perimeter, we take the summation of all the sides. Now for example, if I say, if you take the plane figure rectangle consists with four sides, as you can see in the figure. So it has length and the breadth. So basically you can add all four sides of the rectangle and you can calculate the perimeter of the particular rectangle. Similarly, in square, you can also either take the summation of the all four sides, or you can take a length of one side and you can multiply by 4, since all four sides are equal in a square. Similarly, if you take a triangle, you can take the sum of all three sides, then you will end up with the perimeter of that particular given triangle. So these plane figures you have already studied in your previous grades, so it is just a recap for you to memorize for the upcoming lessons. Also, if you take a circle, we calculate the perimeter, or in other words, we use a special term called circumference of a circle. We use the equation C equal 2 pi r. As you can see in the perimeter column, 2 pi multiplied by r stands for the radius. Pi is a constant value. Either you can represent as a fraction as 22/7, or you can write in decimals as 3.14. Basically, this pi value they will give in the examination paper either as a decimal value or a fraction value. So in this chapter we are going to learn about how to calculate the sector of a, or in other words, if I say the arc length of a sector and the perimeter of a sector. These are the two main areas we are going to focus on this chapter. If I repeat again, we are going to calculate two components. One is the arc length of a sector. The second one is the perimeter of a sector. So before moving on to the calculation, I would like to share some basic questions with you for your exercise. You can refer these images and do the calculations for to find the perimeter of rectangle, square, triangle and the circle. So let's move forward with our lesson. Sector of a circle. As you're aware, if I take a portion of a circle, as you can see in this image, which is highlighted in yellow, the sector where they named as with the angle ACB. So if you take the whole circle, the part of a circle with two radii, which is AC and CB, this particular portion is referred as a sector of a circle. So the sector of a circle always depends with two radius and especially the angle. So we say angle at the center. This angle can be varied based on the size of the sector. If you take the second image of, as I pointed here, which is a semicircle, it is a half of a circle. This also known as a sector of a circle, but we give a special name since it is a half of the circle. We called it as a semicircle. And if I take another example, as you can see, this particular figure, which also a sector of a circle, which is the quarter of the circle. As you can see, the magnitude or the angle theta value here represents 90 degrees, whereas in a semicircle the theta value represents 180 degrees. So as you can see, if I take the whole circle, and if I want to calculate the length of this particular whole circle, or in other words, I say the circumference of the circle, as you all already aware, we use the equation C equal to pi r. That is in order to calculate the circumference of the circle. Since the sector of a circle refers a portion of this particular or this entire circle, we rewrite the equation, or we write the equation for arc length as follows. As you can observe this image, this is a sector of a circle. The arrow marked place is the arc length. So in order to find the arc length, the equation we must use as theta over 360. Theta represents the given angle over 360. 360 refers the magnitude or the angle of a complete circle. So since the sector refers a portion of a circle, we write theta over 360 into, as you all know, the whole circle circumference refers to pi r. So this is portion of a circle, in other words it is a sector, so we multiply into 2 pi r. Therefore the equation we use to calculate the arc length of a sector of a circle is equals to theta over 360 into 2 pi r. So let's look at a simple example and we'll try to understand how to apply this particular equation to find the arc length of a sector of a circle. So as you can see this particular example, this sector is with the magnitude of 60 degrees and the radius of this particular sector of a circle is 7 centimeter. So the very first question says, what fraction of the circumference of the circle in the figure is the arc length of the shaded sector? Since we know the complete circle, the angle refers to 360 degrees, out of which the sector contains 60 degrees. So 60 over 360, which means 1/6 of the portion takes for this particular sector. The second question is, find this arc length. So as I mentioned, in order to find the arc length of a sector of a circle, we use the equation theta over 360 into 2 pi r. Since theta over 360 we already found, which is 1 over 6 into 2 multiplied by pi refers 22 over 7, which is a constant value, into the radius of the sector is 7 centimeter. When you are performing calculations, always you make sure to write the units of the particular length, whether it is meter or centimeter or any given value or any given unit. So since I have mentioned all the values, now it is the time for us to do the calculation. So as you can see, the denominator 7 value, and this particular 7 I can eliminate. So I ended up with the numerator values with 1 multiplied by 2 multiplied by 22, which is 44 over 6 centimeters. If you further want to simplify, you can simplify this by dividing 2, and you can write 22 over 3 centimeter. That is the arc length of this particular sector of the circle, or in other words, the arrow pointed this particular length, which is 44 over 6 centimeters. So this is a very straightforward question where you will get the radius of the sector and the angle of the sector, and directly they will check and they will ask you to find the arc length of the given sector of the circle. Let's look at another example in a different perspective. So as you can see the screen, it shows the arc length of the sector in the given figure is 11 centimeter. Find the angle at the center of this sector. So as you can see in this particular question, the arc length is given, which is 11 centimeter, and the radius of the sector would be 9 centimeter, and the question refers us to find the angle at the center, or in other words, the theta value. So as you can see, you can write the equation as arc length is equals to theta over 360 into 2 phi r. So the arc length value is 11 centimeter. Theta over 360 into 2 pi stands for 22 over 7, and r stands for the radius, which is 9 centimeter. As you already have the knowledge of subject of a formula, you can subject the value theta on here. If you don't know how to subject a given term in an equation or in a formula, you can refer to my video, which comes under formula part 1, part 2 and part 3 in my channel. So once you simplify these values, or in other words, you can keep the theta value on the right side of the equation, all the denominators value you can shift to the opposite side of the equation. Since the denominator's value carries the division, when you shift to the opposite side of the equation, it changes into multiplication. All the multiplication values on the right side, when you shift to the opposite side, will changes into division, as you can see in this line. So by simplifying these numbers, you can ended up the theta value as 70 degrees. Therefore, the angle at the center of this particular sector of the circle is 70 degrees. Please try to do this exercise on your own without referring these steps, and if you come across with difficulties in calculations, please leave your comments so I will be able to contact you in person, or I will be able to help you further on this section. Let's look at another example for your reference. So as you can see, this is a sector of a circle, or in other words, as I told you, there are two radius with one arc length. So the question is for us to find the arc length of this particular sector. So as you aware, the equation we use to calculate the arc length of a sector of a circle is theta over 360 into 2 phi r. In this question, theta refers 90 degrees. So 90 over 360 into 2 into pi value refers 22 over 7 into the radius of this particular sector is 7 centimeter. 90 over 360, when you simplify or when you divide by 90, the numerator value you get 1 and the denominator value you get 4. Also, you can simplify denominator 7 and with this numerator 7. These 7's two values can be eliminated. So the remaining values are 2 multiplied by 22, which is 44 centimeter. Further, when you simplify 1 over 4 multiplied by 44 centimeter, you will ended up with the answer as 11 centimeter. Since 44 you divide by 4, so the arc length of this particular sector of the circle would be 11 centimeter. So in your examinations, either the examiner directly will give you the angle of the sector of the circle and the radius, and they want or they ask you to find the arc length, or they will provide the arc length value or the arc length and will test you or will ask you to find the theta value or the radius. So these are the possibilities that you might get for this particular question. So now let's discuss the next section of this chapter, which is finding the perimeter of a sector of a circle. So perimeter refers, as you aware, in a given plane figure or in a given close-ended plane figure, you take the summation of all the sides. Since a sector of a circle contains with two radii and an arc length, the perimeter of the sector calculation goes as arc length plus radius, or in other words you can write arc length plus 2 times of radius. Both refers the same meaning. So if you write as an equation, you get theta over 360 into 2 pi r, which is already you aware this particular portion, which is theta over 360 into 2 pi r, refers to the arc length plus 2r, which means this particular length and the other length. It's the two radius values, 2r. So when you add 2r with arc length, you can derive to the perimeter of the sector. So let's look at a simple example question and we'll try to understand how to calculate the perimeter of this particular sector of a circle. So as you can see, the radius is 7 centimeter and the angle given is 90 degrees. So the equation of the perimeter of the sector of a circle is theta over 360 into 2 pi r plus 2r. So theta refers to 90 degrees, 90 over 360 into multiply by 2 into 5 refers 22 over 7 into the radius is 7 centimeter, and here this should be, this is not multiplication, this should be a plus 2r. There's a small error, typo error here. This shouldn't be multiplication, this should be plus 2r. As you can see in the equation, it is plus. So 90 over 360, when you simplify that, you get 1 over 44, 1 over 4. So 2 you can multiply with 22, which is 44, and you can eliminate this 7 value, plus 2 into 7, which is 14. So 44 divided by 4 is 11 plus 14. So the arc length is 11 centimeter plus 7 centimeter plus 7 centimeter, that is 14. So 11 centimeter plus 14 centimeter is equals to 25 centimeter. So that is the perimeter of this particular sector of the circle. Let's look at another example, the different perspective. So the question says the perimeter of a sector which is 2/3 of a circle is 260 centimeter. Find its radius. So theta value is not directly given in this question. Instead, it referred as a fractional value, which is the 2/3 of the whole circle. So first we'll calculate the arc length, because the question says for us to find its radius. Because directly when you apply the equation theta over 360 into 2 pi r plus 2r will be little complicated for you. So therefore first we will calculate the arc length. 2 pi r into theta over 360, so 2 multiplied by 22 over 7 into r, value is unknown, so we need to find the radius, so we write r into 2/3. So when you simplify these numbers, you will ended up with 88r over 21. So that is the arc length. So next we can move on the perimeter of the sector. So we already know the perimeter of this particular sector of the circle is 260 centimeter. So So I can write the perimeter of the sector is equals to 88r over 21, which is the arc length of this particular sector of the circle, plus 2r, which is equals to 260. As you can see, the left side of this particular equation, 88r over 21, which is a fraction, and here we have 2r, so the denominator value is 1. So when you simplify this fraction, you get the LCM as 21. So 88r plus twice of 21, which is 42r, equals to 260. So the particular 21 denominator value was shifted to the opposite side of the equation. That is why here it's mentioned as multiply by 21, because on the left side it remained as a division, divided by 21. So when I shift the value, the division becomes multiplication as multiply by 21 on the right side of this particular equation. So this particular section is a calculation of a simple equation. So 88r plus 42r is equals to 130r. 130r equals 260 multiplied by 21. Since I need to find the value of r, I subject r here. So 130 multiplied by r, that is 130r. So between 130 and r, I find multiplication. So I shift 130 to the opposite side of the equation, then it changes to division. That is why 260 multiplied by 21 over or divided by 130. So now I can simplify 260 and 130. 130 divided by 130 is 1. 260 divided by 130 is 2. So numerator value remains with 2 multiplied by 21, that is 42. Therefore, the radius of the particular circle is 42 centimeter. So these are the two sections that initially we cover under this video. So one is calculating the arc length of the sector of the circle, so which is the very simple equation, arc length equals to theta over 360 into 2 pi r. And the next section that we discussed, calculating the perimeter of a sector of a circle, which means arc length plus 2r, or in other words, summation of 2 radius and the arc length will gives you the perimeter of a sector of a circle. So with this section I will conclude this video. You can refer your mathematics textbook, the very first chapter of the grade 10 lesson, and you can try on those given questions. So the next section of this particular lesson is calculating the perimeter of plane figures which are contains the sectors of the circle. That will be discussing on the next video. Thanks for watching, my dear students. Please watch this video a couple of times and try to get understand to calculate the arc length of a sector of a circle and the perimeter of a sector of a circle. So thanks for watching this video. Please like and share this video and subscribe my channel AK Maths. Thank you very much.